For the longest time, there's been this really simple, powerful idea that your weight when you're born is directly connected to your future, your health, your education, even how much money you make. It's been a cornerstone of how we think about public health. But what if it's not that simple? What if that simple idea has been hiding a much more complex and honestly, a much more fascinating story?
So let's really get into it. Is your fate sealed the day you're born? Today, we're going to pry open a black box in fetal health, and what we find inside really challenges everything we thought we knew about that connection between our start in life and where we end up.
So this all kicks off with a puzzle that has, well, really stumped researchers for years.
On one side of the coin, you've got this big idea called the fetal origins hypothesis. And it basically says that what happens to you in the womb can kind of program you for certain outcomes later in life. For ages, low birth weight has been the #1 red flag here, the clearest sign of a tough start.
But here's where it gets weird. When scientists actually try to measure this link, the results are, well, they're all over the map. Sometimes the connection is super strong, other times it's barely there, and sometimes it just vanishes. It's like there's some hidden mechanism, this black box, that's been messing with the results. Until now.
It turns out the key to cracking this whole thing open is realizing something fundamental we've been missing. Not all low birth weight is the same. There's a critical difference we haven't been paying attention to.
Okay, let's get the technical term out of the way. It's called intrauterine growth restriction, or IUGR for short. That's just a clinical way of saying a fetus isn't growing as fast as it should be. But, and this is the whole point, it turns out there are two very, very different ways for this to happen.
And this slide, it just lays it out perfectly. On the left, you've got symmetric IUGR. The key word is symmetric. It means everything is proportionally small. The body, the head, the brain. It's the result of an early, system-wide problem. Then on the right, you have asymmetric IUGR. This is totally different. It happens later in pregnancy, and it's an adaptation. The fetus essentially makes a choice to protect its most critical asset, the brain. So the body is small, but brain growth is spared.
Now, this whole idea of brain sparing, it's not just some nice theory. The evidence is, frankly, pretty stunning, especially when you look at one particular outcome. Think about it, right? If one type of growth problem affects the brain and the other one actively protects it, you'd expect to see a massive difference in something like cognitive ability down the road. And guess what? That is exactly what the data shows. Okay, look at this graph. It basically tells the entire story in one picture. The green and blue lines, those are kids with no growth restriction and kids with that brain-sparing asymmetric type. They're almost identical, but then look at the red line. That's the symmetric IUGR group. The entire curve is shoved over to the left. It's a clear, undeniable picture of lower average IQ scores. The data just couldn't be clearer.
And the researchers themselves, they just nail it with this quote. This isn't just a coincidence. It is powerful evidence of a real biological mechanism where the fetus is literally adapting to protect its own brain. It's incredible.
So let's put some hard numbers to that graph, because this is where it gets really stark. For asymmetric IUGR, the brain-sparing kind, the hit to IQ is pretty small, about a 1.2-point drop on average. But for symmetric IUGR, we're talking about a 4.1-point drop. That is more than 3 times bigger. That's the real-world cost of that early, system-wide disruption we were talking about.
But, and this is a really important but, we can't just say one type is better, because while their cognitive futures look different, their physical health risks, things like congenital malformations, are equally high for both groups. So both of these conditions are serious, they just impact a child in very different ways.
So that leads to the big question, right? Why? Why do these two totally different things happen? Well, it all comes down to timing.
This timeline lays it all out. Symmetric IUGR, the one that affects the whole body and brain, is usually caused by some kind of insult really early in pregnancy, first or second trimester. That's when cells are dividing like crazy everywhere. A problem then has permanent, widespread effects. Asymmetric IUGR, on the other hand, is caused by problems that pop up late in the game, in that third trimester.
And it's not just when it happens, but what happens. The early problems that lead to the symmetric type are things that directly mess with cell division, like infections, genetic problems, or really severe malnutrition. The late-term issues that cause the asymmetric type are more about the placenta not working right, maybe from high blood pressure or poor nutrition, which then triggers that amazing brain-sparing adaptation.
All right, so this is all really fascinating science, but let's get down to it. Why does this actually matter in the real world? Why is this distinction so important?
It matters because, for decades, we've been doing something that, in hindsight, seems kind of crazy. We've been lumping these two totally different groups together and just averaging out the results. By treating all low birth weight as one single thing, our research has been blurry, and that means the policies we design based on that research might be aimed at the wrong problem or at the wrong time.
And what this means for policy is, well, it's a game changer. The takeaway is simple. Timing is everything. If you want to prevent those big cognitive deficits that come from symmetric IUGR, you have to intervene early, in the first or second trimester. A program that helps in the third trimester might make a baby weigh more at birth, but it could be way too late to fix a brain growth problem that started months earlier.
This table really brings it home. Look at a program like Medicaid that gets women into prenatal care early. It might be doing incredible work preventing symmetric IUGR and protecting brain development, but its full value could be totally missed if we're only looking at birth weight. On the flip side, a late-term nutrition program might look like a huge success because it boosts birth weight, but we could be overstating its long-term social benefits if that critical window for brain development has already closed.
So what we've seen is how this one piece of research cracks open that black box and proves that not all low birth weight is the same. It forces us to ask a really tough question. If we've been missing this, how many of our policies are based on blurry averages that actually hide the very people we're trying to help? It really makes you wonder, what other life-changing details are still out there, hiding in plain sight, just waiting for us to ask the right questions?